All right, modeling with trig functions. We're going to talk about some different terms today and show how to actually write equations using information given about periodic data. So first, a term frequency. Frequency is the measure of the number of cycles per unit of time. So it might be per minutes, per seconds, so on. The frequency is actually the reciprocal of the period. So if you know the period of the data, you know that you can figure out the frequency by taking the reciprocal. A measure of frequency, for instance, a measure of length is like centimeters. A measure of frequency is a hertz. 1 hertz is 1 cycle per second. It's one that you'll see quite often. Okay, and so using frequency, let's go ahead and try a problem here. If a tone has a frequency of f of 3,000 hertz with a maximum pressure P of 2 millipascals, write and graph a sine function. Okay, so let's focus sine function that gives the pressure P as a function of time. Okay, so we know that this is our time axis here. This is our pressure axis here. Okay. And in order to write a sine function, we'd have to think of y equals a sine b x minus h plus k. Okay, in that format. So the things we really want to find out are what's a, what's b, what's h, okay, and what's k. Okay, and so kind of looking at this, some key terms. The word maximum tells you how high you're going in terms of your pressure. So our maximum would be 2, and if we were to think about at a time of 0, we're obviously going to have a pressure of 0. Okay, so at the beginning of time we're going to have 0, and that actually tells us that our sine function starts here, which is true if you think of the pattern for sine functions. You start at 0. You start your cycle at 0, you go up to a maximum, you then go back to 0, you go to a minimum, and you end at 0. That's one complete cycle, or the length of one period there. Okay, so when I look at this, I'm at 0 right away, which means I'm not moving my graph right or left at all. So h is 0, I don't move it. Okay, my k value, well, I'm starting here and I have a maximum of 2. Well, that means I'm not going to have to move my graph up or down either. Okay? I'm starting at 0. Now, if I was starting, say, right here at 2 or at -2 or -1, then I'd have to move it up so that I hit 0 to begin with. So my h and k are pretty easy in this one. There's 0. So that leaves us with a and b. Okay, well, it does tell us that it has a frequency of 3,000 hertz. And remember, frequency is the reciprocal of pi, or reciprocal of period, so you can think of 1 over the period is your frequency. Or, better yet, if you know f equals 3,000, okay, well, f is also equal to 1 over the period. And so mathematically, I know that most of you know, hey, we can just flip it and do the reciprocal that way. Just mathematically show you that's 1 over, the frequency, if that's 3,000. And I want to know the period, that's 1 over the period. And I can cross multiply here, that would give me period times 3,000, or 3,000 p. I'm not using p so much because it says the pressure here. 3,000 times the period is equal to 1, and then you divide by 3,000. So the period is equal to 1 over 3,000. Okay, that's how it could be figured out. You just take the reciprocal. It's a lot darn easier. But our period is 1 over 3,000. Now, why is that important? Because in order to find b, remember b is equal to 2 pi over p, or 2 pi over the period. And if I know the period is 1 over 3,000, that's 2 pi over 1 over 3,000, which actually means 2 pi times 3,000 over 1, or better yet, 6,000 pi. Okay, that is our B term. All right, and so my period length is 1 over 3,000. That means if I were to say go, well, let's just say 1, 2, 3, 4, and we'll make that a 0. Okay, and then we'll go 1, 2, 3, 4, make that a 0. Okay, kind of spread out our graph a little. That means right here, from 0 to our end 0, we're at 1/3000. Okay, so this 0 right here is 1 over 3,000. Well, that means this 0 is half that distance, which means this is 1 over 6,000. Okay, which means my maximum is half of here to here. Well, if that's 1/6000th, that means my maximum is 1 over 12,000. Okay, and my maximum, they tell us, is 2. We got 0 max, right? It's at 1/12,000th. This is at 1/6000th. Okay, 0 max, 0 minimum. Now, just so you know, if this is 1/12,000th, that means this one line right here is 1 over 24,000, which means 1 24th, 2 24ths, 3 24ths, 4 24ths, which is 1/600,000, 5, okay, and 6, right? If you were to label these 7 and 8 24ths. This 6 24ths, also known as 1/4000th here. Okay, depending on what your teacher wants you to label. But there you've got it. Okay. There is the graph of our sine curve. Now I'm just graphing one cycle of it. If you want to know, this was 1 out of 4,000. That's where that minimum was. Okay. And our A term, well, our A goes from 2 to -2. That means it has an amplitude. If that's a distance of 4, amplitude is 2. Okay. So our equation becomes y equals A, 2, sine of B. B is 6,000 pi times x, or in this case, x is actually t, right? And y is actually not y, it's p, pressure. And there's our sine function. All right, no h and k that we have to worry about. Okay, hopefully I didn't belabor this too much. I just want to be able to quickly take the reciprocal there, especially with fractions. So, okay, graphs of sine and cosine functions are also referred to as sinusoids. So graphs of a sine and a cosine we call sinusoids. Now the general form of a sine function we just talked about, but just a quick review: y equals a sine b times x minus h plus k. All right, and graph of a cosine, y equals a, pretty much the same. It's just you have cosine in there. All right. Now I'm not going to go through what each of those do. If you really need that, then please go back and reference the 9.5 lesson. Okay. So writing a sine function. So what I'm going to look at here, my strategy when writing these to find my different terms is first I list off to the side. I'm looking for A, B, H, and K. Okay. When I'm in this form, y equals a sine b of x minus h plus k. And please note there's multiple equations that you can come up with because of phase shifts. And this one says write a sine function, so we have to use sine rather than cosine. But the strategy I'm going to use is I'm going to take and try to move my axes so that they line up perfectly with my graph, as if my graph was actually being centered over the y-axis and starting at an x-axis. So for instance, this y-axis, notice if I move it up to here, I now have a new midline, and that midline is normally where we'd see the y-axis before anything has been moved up or down. Okay? And how do I move this axis up to here? Well, think to yourself, really what I'm doing is I'm adding 1 vertically. Well, the thing that adds 1 vertically is our k value. So our k is 1. And what that's done is it moved our midline up. Okay? I mean, technically it moved the graph up, but we're thinking in terms of midline. It's a little easier to think about. Move the y-axis up. Okay? And then if I'm graphing a sine function, you know, I look for places where my curve hits perfectly. It hits perfectly right here. So if I wanted to have a negative sine function, I could. It's perfectly right here. And I think I'm going to use this one right here. So I'm going to move my x-axis to this location right here. And so what we need to do is figure out how much we moved this way. We know we moved up 1. Okay? And so that's our k. How much are we going to move this way? Well, if you kind of look at it, this is 3 pi over 4 right here. This is pi over 2. So if this is pi over 2, that means this is pi over 4. So I can just count up 1 pi over 4, 2 pi over 4, just pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4. This line right here represents 5 pi over 4. So what have I done? I've moved my graph to the right, 5 pi over 4. Now, somebody say, well, why is there a minus there? Because remember, when you move to the right, it's a negative, right? You're subtracting, so it's kind of counterintuitive. So 5 pi over 4. So what we've done, that happens to be our h value. Oops, sorry about that. All right, let me go back here. All right, so now we're there, and then we look at, all we need to do is find a and b now. Well, I kind of look at this, my a value, how far above the midline is it? Well, it's a half, so a is 1/2. Okay, you have half below and half above. Okay, and then b, how many cycles are there? Well, it's a little tougher. It's number of cycles between 0 and 2 pi, so I guess you may even want to start with that, but I'm going to trace them here. So I start here, okay, and I rotate to about right there. That looks like 1 cycle. Up there, and keep going. Looks like about 2 cycles. And about 3 cycles. So it looks like 3 cycles. Okay. Very good. So we've got y equals a, 1/2, sine b, 3, times x minus 5 pi over 4, plus 1. Okay, now notice I said minus 5 pi over 4. When we put it in here, it's still minus. So I guess technically you could have said, hey, it moves to 5 pi over 4. So we just could write it like that, and the minus is already taken care of. Okay. So if you want to think of it that way, however it makes you think. But when you're going to the right, remember it's minus h. Okay, so there should be a minus there. All right. Now you kind of may have caught me hesitating there for a second. You could actually calculate b by using your distance here from max to min. Okay, that's half of a cycle. All right. So I could have said, well, a half a cycle is from 3 pi over 4 to 13 pi over 12. Okay, or not right there. It's been like right there. All right. So a full cycle, how much would that be? Well, if you think of it in terms of 12, 3 pi over 4 is actually 9 pi over 12. Right, and 9 pi over 12 to 13 pi over 12. This is why I was kind of hesitating. This could be called 9 pi over 12. This could be called 13 pi over 12, right? This line and this line. And so if I really want to know what one complete cycle is, calculate it perfectly to get up to this maximum again. So we go from here to here. Well, to add another 4 pi over 12, pi over 12. Right, that's where I'd end up being. So like from there, it'd be 17 pi over 12. Well, that's 17 pi over 12. The distance from 9 pi over 12 to 17 pi over 12 is, in other words, you're subtracting there. That's equal to 8 pi over 12. Okay, and 8 pi over 12 reduces to 2 pi over 3. Okay, that's the length of the period, and then, so that's what P is. And so B would be equal to 2 pi over P, which is the same thing as 2 pi times 3 over 2 pi, which reduces to 3. Now, I will say that that's a lot of algebra to find out there's 3. Based on this lesson, all you're going to have to do is count. Okay, you could visually look at it, but that's how you could figure it out. All right. What we're doing with our assignments and our lesson, you can just count them up. Okay, but there we've got it. It's easier to move the axes, I'll just say that much. Okay, let's go ahead and try another one. Write a cosine function for a sinusoid shown. So we have to be y equals a cosine b of x minus h plus k. So we need to know a, b, h, and k. Let's go ahead and find out b first, since that's where we just left off. Okay, so I'm going to look at some maximums here. So here to here, that's one complete cycle. So I'm going from max to max. So 5 pi over 12 to 17 pi over 12 ends up giving me 9 pi over, excuse me, not 9 pi over 12, it gives me 12 pi over 12. Okay, and that's my period. So this length right here from there to there. Okay, and that gives me pi. And so B, remember, is 2 pi over P, which is 2 pi over pi, which equals 2. Okay, so my B term is 2. Now, once again, oops, let's make that a lowercase b. Once again, you probably could have counted. You say, well, I start here right before 0, and I go to there, and then I go right before 2 pi. So it looks like there's 1, 2 cycles. So B is 2. Okay? But once again, there's how you do it algebraically. Okay, let's go ahead and look at the midline here. So negative 6 to 2 is, well, that's 8. So half from negative 6 up to negative 2. There would be my new midline. And let's use a different color here. So we think we're going to have to, in order for us to split our graph in half perfectly, what we're going to have to do is move our y-axis. I can't get a straight y-axis here. There we go. Our y-axis down 2, which is our k. All right. And then in order for us to get a cosine function that's going to hit perfectly at the top there. Now I don't have to hit at the peak. I don't have to start at a maximum, but I could start at a minimum, but it's kind of nice if I start at a maximum there. Okay, I'm going to move from 0 all the way over to 5 pi over 12. Okay, and so my h is 5 pi over 12. All right, and my a, it looks like, remember, I'm 4 above the midline, 4 below the midline, so a is 4. All right, so my equation, y equals a, which is 4, cosine b, which is 2, times x minus 5 pi over 12, because I'm moving to the right, it's a minus, all minus k, which is 2. There we got it. Now, once again, there could be multiple equations you can come up with, like your b term could be, not your b, but your h term could be different. Okay, let's try a story problem here. A pendulum on a grandfather clock is swinging back and forth as it keeps time. So if you've never seen a grandfather clock, you have a pendulum that swings back and forth. Okay, so here's my pendulum. It's swinging back and forth as it keeps time. All right, so go ahead and swoops this way, and then swoops this way. All right. A device measuring the distance of the pendulum is the pendulum is above the floor as it swings back and forth. So we have this device measuring the distance, the height the pendulum is above the floor as it goes back and forth. At the beginning of the measurements, the pendulum is at its highest point, 48 centimeters. Okay, so it starts its measurement right here at 48 centimeters. Exactly 1 second later, it's at its lowest point, which would be down here at 16 centimeters. And to go from here to here, it took 1 second. And then 1 second later, it's back at its highest point at 48 centimeters. Okay? And so from here out to here, it's back to its highest of 48 centimeters 1 second later. Okay? Write a model for the height, h in centimeters, of the pendulum as a function of time. So we want h of t. So h of t equals, well, here's what initially comes to my mind. So if I have this graph of this, and kind of looks like this, I know this pendulum starts at its highest point right here of 48. Okay, it swoops down to its lowest point and then back up to its highest point again. Okay, now just a quick sketch here. Lowest point at 16 and then back up to its highest point of 48 again. Okay, this is the ordered pair 0, 48 at 0 seconds. This would be the ordered pair. Well, that was not productive. Okay, this would be the ordered pair 1, 16. We're thinking of height and time. Okay, at 1 second, we're at 16. And then back at the top 1 second later, so at 2, we're back at 48. Okay, and so what I'm thinking is this looks like a cosine graph. Okay, so I'm going to use cosine here. All right, and with cosine, I need to know A, B, H, and K. Okay, and now looking at this, I can think to myself, well, I could move just like I have been doing, I could move my midline to right here, which would split 48 to 16 in half. So I think to myself, well, what's halfway between 48 and 16? Well, that would be 32, 48 and 16. Well, 48 plus 16 divided by 2 is 32. Okay, either way, that's a plus 32 on the k value, right? So we're going up 32. That is our k. All right. And then in terms of my b term, what I need to be thinking to myself, well, I'm going from here to here in one complete cycle. Well, that's from 0 to 2. That means p, we add a piece here. Let's go ahead and switch up some colors here. P goes from here to here is equal to 2. Well, that means B, which is 2 pi over P, 2, which is pi. Okay, so now we know B. It doesn't look like we have to move it horizontally, so H is 0. And then A just says, well, how far above the midline, how far below the midline are you? Well, from 32 to 48, it just happens to be 16. So that's 16. Or once again, you can add 48 plus 16 and divide by 2. Okay, or excuse me, take 48 minus 16 and divide by 2. All right, and so that means y equals a cos b x minus h plus k. All right, and I guess x is not x, it's t. So we now have h of t is equal to a, 16, times cosine of b, which is pi, minus h, which is just t. I guess just say pi t, and then plus k, which is 32. And there we go. All right. I think we got one more. Yep. Okay. So using technology, the table below shows the average monthly temperature for a particular city. Use the regression feature on your calculator. Write a sign model that gives t as a function of m. All right. So in order to do this one, we need access to a graphing calculator. So let me go ahead and put a graphing calculator on the screen here. Okay, and what we're going to do is we're going to use the stat function on it. So I'm going to turn it on here. Go to, click that there, and go to stat, and we're going to edit. So I'm going to hit option 1, and in our list feature, I'm going to put the m, our monthly. So we'll just 1, 2, 3, and so on. Okay, and then in list 2, we're going to go ahead and put the temperature, and temperature is going to be our 35, our 38, our 42, 47, 54, 58, 63, 62. Just helps me saying I'm 56, 49, 42, and 38. Okay, and now what we're going to do, we're going to go ahead and quit here, and we'll go to stat, and we want to calculate, and we want to go down to sign regression, and well, I got to actually find sign regression here. There we go. And I'm going to hit enter, and there we got it. And one thing we want to make sure is that we take a note. Let me go ahead and switch this around so I can actually write on my display here. Take a note that the form that it's in. So we have y equals, oops, my pen to work here. Y equals a sine bx plus c. So it says plus c and not minus c. Okay. So if I write that out, y equals a times sine bx plus c, okay, and all that plus d, oops, plus d. Okay. And they tell us our a, b, and c, a, b, c, d terms. Okay, so they actually tell us that our a, I'm going to round to the nearest hundredth here, is 13.13. Our b is 0.53. Our c is negative 2.24. And then our d is 48.9. Okay? And so we're going to go ahead and put it in the format they give us. So I'm going to substitute these in. I get 13.13 sine of b, 0.53, x plus, oops, I guess it's minus now, minus 2.24 plus 48.9. Okay? And so this is an okay form if they ask you sign regression. Just the key piece you need to note here is usually this is our h term. So if you think of our standard form, the form we're using, y equals a sine b of x minus h plus k. H is our horizontal shift or phase shift, whereas b is outside of the parentheses and x is by itself. X has a coefficient of 1. C doesn't do the same thing H does unless you actually take B outside of the parentheses. So if you move this to the outside, then C will do the same thing H does. You have to factor out that 0.53. So like I said, this right here is okay, However, if you want to see like what your phase shift is, so we should have y equals 13.13 sine of, we'll go ahead and factor out 0.53, which means we have to divide 2.24 by 0.53, which actually gives us negative 4.23. Right? And then add the 48.9 to that. That right there is this format. Okay? So if you want to see this format, you got to go one more step there. I guess we didn't have to go quite that drastic. One other problem that I've had, and maybe some of you caught it right away here, is that, well, first, that I can't draw a line correctly, but second, I haven't used M and T like they've asked. So, like, this should be my T, this should be my M, this should be my M, this should be my T. Okay, so there we got it. Very good, based on these here. Okay, I think that's all I've got for you.